Good morning, everyone. Welcome. Welcome to the very first day of the Italian Tech Week 2025 and to the very first masterclass of this edition. All the masterclasses are brought to you by Italian Tech Academy and Talent Garden, two organizations aimed at upskilling and training professional entrepreneurs, startuppers in innovation and tech and digital skills. And today we have the pleasure to have with us Giuseppe Perrone, a partner Italy, and we're talking about AI explainability because we all use AI, but sometimes we know that we have to verify the inputs that we have, and so we are talking about this very interesting topic, and I leave the stage to Giuseppe.
Thank you, and good morning, everybody, also from my side. So, as mentioned, we will introduce this topic of AI explainability. I try to investigate a little the elements that we should consider when we apply AI models and develop AI solution, and we will combine the framework of explainability using both technology, AI and blockchain. So we will investigate this topic. I would demonstrate you with a real demo how we can combine both technologies, and we will also analyze how AI can impact on the real value of business of public administration and private sector, but also considering the compliance implication that we should take in mind in terms of compliance. So we will analyze in this masterclass the introduction to explainability. How does it mean apply a concept, a framework of explainability for AI solution? After, we will analyze a logical model that combine explainability, AI, and blockchain, and we will analyze the real use case with a real demo. So, first elements that I would to mention is the obstacles in the AI adoption. We have studied different and we have conducted different research that demonstrate the classical AI phobia. The AI phobia are a sum of different phobias that the human can have applying AI solution, and that are referring to the phobia of substitutability, the adoption, and also the knowledge about this kind of technology. So when we use AI, we have an initial first issue that is related to this black box. So we don't know exactly what the model realized in terms of inputs and output, and in some cases the internal logic behind can suffer of issues related transparency, related the difficult to interpret what the model reason in order to obtain the outcome. The second element is the bias. So when we trained a model, one of the lack is the lack of transparency related how the model can be trained in terms of bias, in terms of risk, in terms of the decision in order to create trust between parties and between the final goals. And the third is the accountability. Why I can consider my responsibility than the responsibility of the model, how I can automate some decision, and which are the decisions that remain in my hands. The fourth is related to the regulation and compliance. As we know, in Europe we have the AI Act and some of other regulation that evolve in the direction to be transparent, to be affordable, and to guarantee the full traceability of AI decision and the AI model in order to ensure the safety of all organizations that apply this kind of technology in terms of auditability, in terms of compliance. So the pillar of explainable AI regard these 8 elements. So what does it mean, explainable AI? Explainable AI is a set of approaches, techniques and practices that we can use to make AI system decision understandable for all and meaningful, overcoming the opacity of the complex black box in order to ensure for user and developers the capacity to understand which are the output that we can generate and if these output are aligned with the main principles. So the first is transparency. The transparency shows how the model generates the output that we want. Traceability allows that every step of the decision can be followed. The reliability is the capacity to demonstrate that the model is consistent, but especially is repeatable in terms of decision and in terms of action. If I repeat the same prompt, I would to obtain the same answer. Responsibility, identify who made or be authorized in the decision, and we have also elements related fairness and non-discrimination. So does it mean that when we trained the model, there are not influenced respect, as I said before, bias or other constraints? User understandability is the power to understand how the decision is taken in a way to be simple, to be useful. The other aspect is related to regulatory compliance, so the application of regulation and the legal standards, and the verifiability, so in order to allow the external control and to have capacity to verify in independent way the decision of the model. So considering this kind of principle, there are two main explainable AI models. The first are model specific. When we approach specific model, we are approaching algorithmic specific. They use internal structure for the explanation. So in this case, we have the classical decision tree or the capacity to use a neural network in order to allow the outcome of the models. In the other way, we have model agnostic. When we mention model agnostic, we use methods that work independently of the underlying algorithmic and provide post-hoc explanation. That means that this black box can, how this black box has been trained in terms of reinforcement learning or learning that we have done. So in the first case, obviously, in the classic decision tree, we have split the database and we have defined the decision rules, and based on the threshold that we have, we can create the transparent path from the input to the outcome. In the classical neural network, we use simplified architecture in order to have a specific mechanism that regulated the standard. And in the other way of model agnostic, we use generally technique like LIME. So LIME generates small variation of the input that can be observed and that can be changed and explain how the outcome is obtained. In the classical way of shape, we calculate the average contribution of each variable in order to obtain the outcome. And after we have also feature importance, that is another technique in order to measure the performance and verify how is variable. So at the end, we can apply one technique or the other technique. Is not one preferred way in order to apply a structure of explainable AI. But it's important to consider the different pros and cons of each way. In the first case, we can obtain obtain using model-specific immediate explanation on how we can correlate this input with the outcome, and we can obtain the reasoning model and the reasoning explanation of that. But it's specific. We cannot transfer model by model. Imagine to apply this kind of model for a supply chain is not applicable for a model that we have developed for a finance application, for example. In the other way, model agnostic can be repeatable for different industry specific, but the cons is that the explanation are not fully clear in terms of overall elements that correlate input and output. So we should consider specific computational expense in order to obtain all decision tree. As I said before, we should consider also these three levels of regulation. So the first is the regulation that we have. So in some cases we say that in US innovate, in Asia Pacific they have the ability to replicate the application of AI. In Europe, we have regulated the whole framework of AI. So we can consider in this pyramid three main areas. The first is the technical standard. So the technical standard and the framework are like ISO or like OECD framework or NIST are the specific standard that we can use when we apply AI for our company, and that are specific in order to guarantee the respect of all rules in order to apply AI in my specific context. The soft law guidance, the middle of pyramid, is related to the guidelines and the policies. So in this case, we have the guidelines in order to apply general purpose application of AI. We have code of practice, ethic guidelines, because we should apply AI in a way to be sustainable, to be ethics. And the hard law are related to the respect of AI Act, that is this main directive at EU level that is applicable for all countries in Europe. We have GDPR that is not a law applicable just for AI, but is important to consider in terms of treatment of data, especially sensitive data. We have Data Act and AI law if we consider the Italian legislation. So in the full environment of legislation and regulation of AI, in some clauses of this law, we have references to apply AI in a way to be transparent, to be sustainable, to be traceable in terms of overall application. And in terms of other elements to consider, just to have a clear and full environment, we should consider also the Digital Service Act, how we can apply and we can realize digital services for AI for all digital application, and digital market tax also in order to guarantee the possibility to create a marketplace of application, marketplace of services, and the rules that regulate the economical transaction. So which are the key challenges when we want to apply what I mentioned before in terms of explainable AI to the specific models, to the specific solution? So the main elements are the classical tailored explanation. So we have different stakeholders. Each of these stakeholders has specific goals, has specific elements and benefits that we want to achieve. So we should regulate the need of different levels of detail and obviously languages, because the language, in order to explain a model of AI for a developer, so obviously is completely different of the end user. Explanation should be adaptive, so we should use different techniques, technical for engineers, simplified obviously for end user. And there is also a lack of tailored communication risk confusion, because obviously we could potentially have misalignment in terms of regulation between the application. Imagine to have an application of AI that want to recognize our biometrical parameters. Obviously, there are implications in terms of regulation that we should consider when we apply this kind of explainability. After we have the need of trade-off, so we should consider the balance between the accuracy, the affordability, the transparency also, but maintain at the same time the intellectual properties related to the specific application. So if in a sense, in a way, we should be transparent, in the other sense, we should protect, obviously, and that's it, a crucial element for the classical IT company. We should protect our intellectual properties. We have the side effects, so misleading or oversimplify the explanation. So we should explain a model AI, but we should create and reduce the critical oversight. We don't be in the possibility to expose, for example, vulnerability just to be transparent, because in the other way, if we have some other vulnerabilities, we have other risk, our threats in terms of overall benefits that we want to achieve. And the fourth element is the governance. So we should consider the governance in terms to be structured, to require organizational measures in terms of clear appeal processes, human oversight, the audit mechanism. So at the end, we should balance using different different technologies, how we can ensure explanation are verifiable, but at the same time contestable and auditable. So the model that we want to propose is a logic model that combines the explainable AI model with blockchain. And in order to ensure this final goal, we have identified 3 layers. So as I mentioned before, in the characteristics of how we can ensure our goal, we have a governance layer. So the governance layer guarantees that all explanation become accessible for all users, characterizing all users with a tone of voice related to the information that they can understand, respect the level of explainability that they want to achieve. The second layer is the blockchain. So the blockchain can create the full proof of overall transparency for the data model, for the explanation, and each of these steps are recorded in an immutable way, in a tangible proof way on a public ledger of blockchain. So we should only consider the public ledger, because obviously if a registered or tokenization, notarization of this data or this token in a private blockchain, at the end we cannot obtain our main results. And the first is the explainable AI layer, so the layer that guarantees how AI makes decision, which are the steps to generate our final outcome. How we have transferred this concept in a tangible solution, we have built up these 5 steps. So if we see these 2 bubble, we have for all of these phases the registration on blockchain. And for the last 2, the explainable AI framework application. So in this case, how we can create a solution that integrate auditability, transparency, traceability of the entire AI lifecycle. In the first phase, we collect data and we register the data that we are using in order to train the algorithms, the models. And for each of these data, we create acquisition and registration on blockchain. The second step is the data validation. So obviously it's important to validate the data before to train the models, and we can validate this data using smart contract. Smart contract is an informatical application that with automatic rules that can be inserted in this smart contract can guarantee if the construction of the data used in order to train, used in order to create a reinforcement learning of the model are aligned with the principle that we mentioned before, principle of transparency, principle of auditability, understandability, and so and so. So we certified and we have this proof in terms of tokens for all objects registered. After we have the registration on the data certified, the metadata associated to the reasoning model, and in terms of user interaction and certified inference, we can generate the AI output, and on the blockchain we can register again the steps in terms of elements to be sure that all activities are notarized. The last element, explainability and user transparency, in this case we have human readable explanation through the explainable AI engine that we have created. So in this way, with these 5 steps, we can assure in a dashboard and we can present the AI decision, the explanation, and the traceability evidence for all activities that we have performed. At the end, what we can obtain? We can manage all elements, especially not just in the clear view where all is aligned with our gold standard, but also in order to manage the exception. So in this case, obviously, we can have different exception. We can have exception in terms of data quality, in terms of rollback, in terms of fallback, in terms of retraining. For all of these steps, we can maintain a continuous improvement, reliability, and continuity in AI system. Obviously, because an AI system is not a static system, but is a dynamic system that can be retrained, reinforced every time, depending on the specific characteristic of the environment where we apply. So in this case, also registering and tokenized this exception, we can manage the full life cycle. In the practical use case that I would to show, because I would to move from the theory to the tangible application, what we have designed is an application, for example, of AI to create a match for EU funds. So imagine to have a public administration that want to identify which are the way to select specific funds for funding opportunities of infrastructure, for healthcare, for citizen services. And in this case, we have combined blockchain in order to trace and tokenize each steps in each application of the process and securized the full traceability of these activities. We have combined explainable AI in order to make the system choices transparency, so I can see which are the decision that I take and how are relevant in terms of funding opportunities, and the classical AI tool that create the capacity to realize this matching between my request with a prompt and the combination with the funds that I can obtain. So in terms of steps, again, we have the classical construction of knowledge base. So we trained our models with the knowledge base, in this case, the list of EU funds that we can use. And we can collect, for example, the municipal plans, European calls for proposal. So we have the two lists of elements that I want to match. The second step is the configuration of model prompt engineer. So obviously I'll insert specific instruction for our model in order to generate the output. So the match respect the request in order to compare the municipal plan with the funding opportunities where I can join. And in the execution, there is the interaction between my request and the model. So the uploading of municipal plan and the requesting of the match, and the outcome that is the expected delivery, so the generation of the explanation. All of these steps are traced on blockchain. So we can be sure, in case of control, in case of monitoring, in case of internal auditing, how I can take in this decision than the usage of blockchain. That's it, the process. I don't want to touch each areas of the process, but just to say how we can transform an idea in a process, in an application. Before we will analyze a little this sequence diagram, after we will show the demo. So in this case, we have the user prompt, and all start with a simple user interaction. The user enter in a prompt with their funding request. At that point, the orchestrator kick in dynamically in order to select and configure the most appropriate NLP agent and the language model that I want to use. And obviously, this agent, because we are building this kind of solution with an orchestration of AI agents. So we are applying the technique of AI agentic mesh. I don't know if it's familiar for all, but at the end, we are using agents that can make decision standalone without the usage of human step by step, but are instructed in order to obtain this final goal. So this agent perform semantic analysis, extracting key topics, geographical constraints, funding priority, and for each of these action, the action are recorded on blockchain. After that, I can identify the funding with the call matching. So in this case, in this area, I set up the retrieval augmented generation agents and the model, and the AI can perform the match. So the match from the input of the request of the municipal plan and the funding that I want to use. After we have the explanation generation, so we identify with an explainable agent if the decision taken from the model is clear, human readable, in order to justify the result that we have obtained with the model. So also in this case, I registered all on blockchain. So we have a phase where the agent decide which are the funds where we can apply, and there is another phase where XAI, explainable AI agent, define if all information are transparent, are auditable. So at the end, we have this step of user validation, so human in the loop. That is important because we are considering an AI application, but the human is the final decision of the overall process, define if the output is valid or not, okay? So that's it, the classical way where all is aligned with my idea, with the capacity to match funds with opportunities and all. That's in the case of an exception. So I can identify that there is an exception. So I'll apply, as I mentioned before, a fallback, and the registered also the fallback. I store the hash, how the explainable AI system identify that the match that is performed with the AI model is not aligned with the prevision that I could have. So the typical output that would be logged on the blockchain, and the process are registered in terms of event. But when the fallback is activated, I have a token on the blockchain that registered the first event of incident and registered the second event where all will be aligned. So in this way, when a controller will see how the explainable model work and how I have obtained the final result, I can trace each steps of verification that I have performed. So that's it, another example of reporting. In this case, the error has been identified by the human. So I activate the other steps in order of full stack in order to obtain the real result that I want to achieve. So at the end, we should consider that the error can be identified with explainable model, can be identified by human, but in all of these cases, I can identify a trace of the events that has been realized. And I would to go to the demo. Let me just a second. So, in this case, we have our municipal plan. We upload the municipal plan on the AI application. And in this case, the artificial intelligence model is uploaded in terms of knowledge base with all information of municipal plan and funding opportunities. In this case, I'll ask to the agents to create our match, and there is the explanation of all steps, but also the registration on blockchain. So for each step, if you remembered, I uploaded the funds, I uploaded the municipal plan, and I asked the model to verify the match. So the model generated the outcomes, and for each of these steps, I generated a trace on blockchain with the tokens that will be updated with the status of the research. For each steps of the process, I have in clear the explanation why these opportunities is compatible with the request, and which are the elements of certification that we can verify real time if the registration on blockchain is the same that we are looking now. So that's it, the public blockchain of Ethereum with the second layer of Polygon, that is a public blockchain, and we have identified how combining blockchain plus explainable AI, we can obtain our results. That's it. Another examples in case of exception. So in case of the exception, what we have seen into the sequence diagram is replicated also on the system that we have created. So in this case, we analyzed AI. With the AI models, we analyzed the matching between municipal plan and opportunities of funding. We have the explanation, but in some cases, we could potentially have the correlation between the certification on blockchain that could be not aligned with our request. So in this case, we can fallback the entire decision tree, and we can identify how is not aligned the decision taken by the models with the explainability of overall step. And that's it, how we can transfer all this data in terms of verification of our certification. So in this case, we recalculate the hash and we visualize on the blockchain the final results. So, which are the potential areas where we can apply this kind of explainable AI models plus blockchain? In some sector regulated, so for example, financial sector to contrast the fraud detection or to verify if this phenomenon of frauds is aligned or not with the characteristics of a real phenomenon, or are being identified but is false in terms of auditability of the decision, into the healthcare to assist the diagnosis and the traceability, for example, in the case of imaging recognition for the healthcare diagnosis, in case of supply chain for the route and optimization. So in some of the different processes where it's important to verify how we have used AI, but we should sure that the results are aligned in terms of final outcome. What could be the main benefits? So the reduction of false positives, the certification of audit trail, the stakeholder trust in terms of transparency, and also the integration. Imagine to have different and multiples players that operated in our environment. So each of these players want to be sure that the decisions are good. So which could be the next step? So using this kind of framework, we can obtain dynamic and predictive audits. So we can use AI, but at the same time we can move from the classical static audit trail that are exposed to predictive audit trail before we will use an AI models. We can have obviously an end-to-end transparency between multiple players involved on the same value chain, on the same area of application, and also in a way of full complete innovation, we could potentially federate the governance between multiple actors that want to share specific insight, and thanks to the application of blockchain plus explainable AI concept can support the reinforcement learning of this model. So these three ways could potentially become the future of combination of a better transparency of AI model, but also the capacity to contrast the opacity of AI model to ensure that our decision will be taken in a safety way. Thank you so much, and I hope that has been interesting for you and for the application that we will use in the future. I don't know if there are questions from your side.
If there's any question from the audience, I can pass you the microphone. Oh, sorry. So if there are no questions, thank you very much, Giuseppe. Thank you for opening the first session, and thank you very much for attending this one, and I hope you will be in the next one as well.